My name is Hannah Blake. I am doing my case study on the Gauley River watershed. The Gauley River watershed is located mostly in Nicholas County, West Virginia. This watershed also flows into Fayette, Greenbrier, Webster, and Pocahontas counties. Major tributaries of this watershed include 20 Mile Creek, Williams River, Cherry River, Cranberry River, and Meadow River. This watershed also covers 1,419 square miles. The land use is dominated by mixed forests. Some areas of the land are disturbed by mining, and other areas are used for urban and residential development. The watershed has 3,063 miles of streams and rivers, which all drain into the Upper Canal watershed. The Gauley River watershed is a Category C watershed, meaning that it is primarily used for human health. So a lot of it is used for drinking water and recreational uses. Other designated uses include warm water fisheries and trout waters. The applicable water quality criteria identifies 5 major contaminants with different criteria among warm water fisheries and trout waters, which are broken down even further into acute and chronic criteria. Acute meaning that the 1 hour average concentration of the pollutant cannot be exceeded more than once every 3 years, and chronic means that the 4-day average concentration of the pollutant cannot be exceeded more than once every 3 years. And then the public water supply criteria differs from that. The Gauley River watershed is on the 303D list for aluminum. Aluminum contaminates 37.2 miles of the watershed, which goes from the mouth of the watershed to Summersville Dam. The data available for creating the TMDL came from multiple samples taken from the watershed that found dissolved aluminum, iron, selenium, fecal coliform bacteria, and elevated pH were impairing the stream. TMDLs were then created to restore the stream to standard water quality. The methods used for creating the TMDL came from GPS locations, water samples, and flow measurements. These were collected to represent the pollutant sources and characterize the impact on water quality. So for elevated pH, WVDEP used source tracking and pre-TMDL water quality monitoring to determine the causative sources. Elevated pH is associated with elevated iron, and iron is associated with elevated sediment loads. So reducing the amount of iron in stream significantly reduces the pH. And to reduce the amount of iron and aluminum, a top-down methodology is used. So the source is found and then is backtracked until the in-stream quality criteria is met. For fecal coliform bacteria, failing septic systems, straight pipes, and SSOs were removed. SSOs are sanitary sewer overflows. CSOs and non-point source loadings from agricultural and residential areas were reduced until the in-stream quality for fecal coliform bacteria was met. The recommendations for the TMDL are to reclaim mines, reduce sediment loads, reduce CSOs and remove SSOs, and continue to sample and monitor the water. And referring back to this table, the water quality criteria can be seen. The Gauley River watershed has an average WVSCI score of 69.75, which means that the river is stable, but it still is on the 303D list for aluminum, which affects 37.2 stream miles. And there are still TMDLs for aluminum, fecal coliform bacteria, dissolved iron, selenium, and elevated pH. So, based off of biological data, for waters with regularly scheduled monitoring in the most recent 2-year period, no exceedances of criteria are evidenced and at least 8 observations are available, then the water is not to be considered impaired. With that in mind, different scores were given to different benthic samples from different sections of the watershed. The different scores varied greatly. Some areas were very poor in quality and some areas were excellent in quality, but overall the watershed is leaning more towards poor. That leads us into NPDES permits. There are mostly sewage permits. That's mostly because the stream is a Category C stream, which is human health, and fecal coliform bacteria is not that great for human health. But other permits include stormwater construction, stormwater industrial, car wash, and mining and non-mining. Major contaminants from stormwater construction include dissolved iron, sediment, aluminum, elevated pH. The sources of those contaminants are high sediment loads, dumping, construction, and stream bank erosion. To monitor that, riprap is used to prevent stream bank erosion. Silt fencing is used for high sediment loads, and the water is supposed to be sampled bi-monthly. For stormwater industrial permits, the major contaminants are iron, aluminum, and fuels. Those contaminants come from metals and high sediment loads. And then to monitor that, the equipment is supposed to be inspected and the water is supposed to be sampled. Then for sewage, contaminants are mostly fecal coliform bacteria, which comes from combined sewer overflows, straight pipes, sanitary sewer overflows, and then raw sewage is included in that. To monitor that, wastewater treatment sites are used and the water is supposed to be sampled monthly for fecal coliform bacteria. And there were a couple car wash permits. Contaminants from that include sediment, oils, and chemicals, which come from the oil and gas from the cars, the soaps and detergents from the car wash, and then run off into the stream. And car washes are responsible for monitoring their grit traps and their filters. Then mining and non-mining, the contaminants are elevated pH, iron, and selenium, which comes from mine drainage and historic mine sites. And the monitoring regimen for that is to reclaim mine lands and to sample bi-monthly. And then these are my references.